Hello, hello, hello. I'm Zardos, and today, a day later but still, another challenge from Another Flavor 24. Today we're gonna look into shellcodes, so a bit of low level stuff, but I'm sure TryHackMe, as always, will explain it to us perfectly. If you don't know what AOC is, check out the first link in the description, and if you want to join us, go to the second one, and complete all the previous days. Alright, that's it for the intro, let's go! Here is a short walkthrough video, but here's my own. Now let's read the story. Glitch, the hacker, clever yet disrupted, wrote the script with skills finally adjusted. Shellcode magic to his home with sand, where the secrets of Wereville had carefully penned. Glitch, a skilled but mistrust hacker, was preparing for a tech conference. He was eager to share his shellcode script that remotely accessed his home system. As he worked, he noticed Mayor Malware's henchmen lurking nearby. They're wasting their time. I don't have anything they want, Glitch chuckled. He didn't realize that hidden in his home system was something they desperately sought. A research paper he wrote on Wereville's defenses, a treasure Mayor Malware was eager to obtain. We're gonna learn how to write a shellcode, so we're gonna generate shellcode for reverse shells and executing it with PowerShell. We attack box. So we've got our Kali VM. Let's connect the VPN. We also need to start a VM. We have split screen, so it's probably for the local machine. And we're gonna have credentials. Let's start it. Have credentials. Let's maybe just save them into echo glitch password. Yes, into creds.txt. All right. We also need to start attack box. Let's see if it's running. Can't grab this anytime. There is some problems, so let's go. Parsing error. Amazing. Let's refresh the page. This should work. Also, it's another new topic for me. I never really read shellcodes or understood them, and if you would like to learn more, if I recall correctly, there is a module in PWN College that I'm going to link in the description where you can study more about shellcodes. Overall, PWN College is an amazing resource for all the low-level stuff. So yeah, I highly recommend checking it out. And if you manage to complete all the courses, you might also get belt, like in real dojo. Alright. Enough for the off-top, let's go. Essential terminologies. A reverse shell to his system so tight. He planned to showcase at the tech conference night. Eager to share how his shellcode could impress, he aimed to enlighten, to teach and progress. Before we start, review some important concepts to help you better understand the upcoming content. Shellcode is an advanced topic, but knowing these foundational ideas will make the rest of the material more accessible and engaging. Alright, let's start with shellcode, a piece of code usually used by malicious actors during exploits like buffer overflow attacks to inject commands into vulnerable systems, often leading to executing arbitrary commands, giving attackers control over a compromised machine. Shellcode is typically written in assembly language and delivered through various techniques, depending on the exploited vulnerability. PowerShell is a powerful scripting language and command line shell built into Windows for task automation and configuration management. It allows users to interact with system components and is widely used by administrators for legitimate purposes. However, attackers often use PowerShell as a post-exploitation tool because its deep access to system resources and ability to run scripts directly in memory, avoiding disk-based detection mechanisms. That's a cool one, I knew it. Windows Defender is a built-in security feature that detects and prevents malicious scripts, including PowerShell-based attacks, by scanning code in runtime. Common bypass methods for evading Defender include obfuscating scripts to disguise malicious content, making it harder for the software to recognize known patterns. Another technique is a reflective injection where malicious code is loaded directly into memory, avoiding detection by signature-based defenses. We'll cover the latter one in this task. Now, what is Windows API? It's an application interface that allows programmers to interact with the underlying operating system, giving them access to essential system-level functions such as memory management, file operations, and networking. It serves as a bridge between the application and the operating system, enabling efficient resource handling. The Windows API is crucial because many exploitation techniques and malware rely on it to manipulate processes, allocate memory, and execute shellcodes. Common Windows API functions frequently used by malicious actors include virtual alloc, create thread, wait for single object, which we'll also use in this task for exploitation. We can access Windows API through PowerShell reflection. Windows API via PowerShell reflection is an advanced technique that enables dynamic interaction with the Windows API from PowerShell. Instead of relying on the precompiled binaries, PowerShell reflection attack allows attackers to call Windows API functions directly at runtime. This will enable them to manipulate low-level system processes, making it a primary tool for bypassing security mechanisms, interacting with the operating system, and executing code stealthy. Alright, this is fair amount of new knowledge, so pretty much from what I understand means that code at runtime. So we can manipulate low-level system processes not by compiling binaries, which then would lead to it being detected by, for example, Windows Defender. There are other disk-based antiviruses. We push the command into Windows API and overall the process itself, like purely from memory, if I understand correctly. A reverse shell is a type of connection in which the target initiates the connection back to your attacking machine. Alright, so yeah, we have the victim, we're sending the payload. This is a cool graphic. Yeah, you send the payload, and then it returns the connection to you. So for example, there was a firewall which would block all the incoming traffic, but it would allow outgoing traffic. So if in this place there was a firewall, us trying to directly connect to the victim machine we blocked by it, yet it connecting to us would be pushed. So yeah, let's generate the shellcode. But many malware's minions, sneaky and sly, found his script and gave it a try. They tampered the code, changed port and IP, twist his work with a sinister glee. Let's learn how to generate a shellcode to see what it looks like. To do this, we'll use a tool called MSVenom to get reverse shell. MSVenom is a package from Metasploit. Yeah, if you're in hacking, you probably know what Metasploit is, and MSVenom is a tool that allows you to generate different payloads that are, for example, used by Meterpreter and MS and just Metasploits payloads and exploits. Yeah, alright. In the attack box, open the terminal and enter the command Windows P reverse shell with port. Alright, I will generate the shell. The output will look like the following. You are required to replace the attack box IP with the PLU attack box. If you have a Kali machine like me, if after you connect the VPN, you should have your IP here, or you can just type IPA, and in tunnel 0 you're gonna have your IP. Let's maybe export it. Export IP, and this is not this one yet. It would be somewhere up there. Yeah, it's this 1010 87 17. Alright. Now we can try MSF Venom. Yeah, this was for probably this Java was for Tomcat, if I recall correctly. Windows, yep, that's it. But host it 0, but it's tunnel 0. Let's do 1337. But the file needs to be PowerShell. Alright. Yes, also another cool technique. If you don't know or don't remember your IP, you can always use a interface names. Like for example, I here can use tunnel 0, and MSF Venom will replace tunnel 0 with this IP address. Alright, we can just run the command and let's see what will return. The command above generates a piece of shellcode using MSF Venom. Here is what each part means. Here we choose the payload. Then we set up then we embed into the payload's IP address, so the reverse shell knows where to connect back to, and then the port. So on which port we need to pass the source shellcode, and also here fPowerShell is the file type. And now let's learn about shellcode. The actual shellcode of the output code is hex-encoded byte array, which starts with OXFC, OXE8, OX82, and so on. The hexadecimal numbers represent the instructions set on target machine. Computers understand binary, ones and zeros, but hex numbers are just a more human-readable version. So instead of seeing long strings of ones and zeros, you see something like OXFC. I mean, we can just go to CyberChef for a bit of off-topic and try to convert binary to hex. Let's go with from hex and to binary. Let's do, for example, OXFC. This is fairly short, but if you would have, I don't know, something like this, you see it starts to grow. CD. I don't know. Let's put there also E, B, A. See, and without spaces, if we delete it, it starts to grow. And when there are memory addresses fairly long, even longer than this one, because they are mostly 64 bits, then you end up with really long binary data. Hex, as was said here, made it more readable. We can execute this shellcode by loading it into memory and then creating a thread for its execution. In this case, we will use PowerShell to call a few Windows API via C# code. Below is a simple PowerShell script that will execute our shellcode. Here we have virtual lock at using system. This looks kind of like a C# code. Yeah, that's C# code. No cap. All right. Phew, that's a lot of code, but don't stress, we'll break it down what it does step by step. If you're new to cybersecurity, memorizing these functions is unnecessary. Most pen testers use pre-made or automated tools to run shellcode, so you don't have to know every technical detail to complete the job. No need to worry. Alright, I mean, you don't have to know every technical detail, but it's cool to know what it does and not copy code, because, you know, copying code mostly makes you a script kiddie, and we're learning to be hackers, not script kiddies. You can only utilize scripts made by someone and can't find anything on their own. Alright. Coming back. The script started by defining a few C# classes. These classes use the DLL import attribute to load specific functions from the kernel 32DLL, which is a part of Windows API. Virtual alloc allocates memory in the process's address space. It is commonly used in scenarios like this to prepare memory for storing and executing shellcode. Then we create a thread in the process. We execute a shellcode that has been loaded into memory, and then this function pauses execution until a specific thread finishes its task. In this case, it ensures that the shellcode has complete execution. These classes are then added to PowerShell using add_type command, allowing PowerShell to use these functions. Next, the script stores the shellcode in the buff variable, a byte array. An example below shellcode placeholder is just there to show where you would insert the actual shellcode, earlier generated through MS Venom. Usually you replace it with the real shellcode represented as a series of hexadecimal values. These hex values are instructions that will be executed when the shellcode runs. Yes, you saw it here, and we just skip the whole part of it. Alright. The virtual lock function then allocates a block of memory where the shellcode will be stored. The script uses the following arguments: 0 for memory address, meaning that Windows will decide where to allocate the memory; size for size of memory block, which is determined by the length of the shellcode; OX3000 for the allocation type, which tells Windows to reserve and commit the memory; and X40 for memory protection. The memory is readable and executable, necessary for executing shellcode. After memory is allocated, the Marshall copy function copies the shellcode from the buff array into allocated memory address, preparing it for execution. Once the shellcode is stored in memory, the script calls the createThread function to execute the shellcode by creating a new thread. This thread is instructed to store function memory address where the shellcode is located, address. The script then uses wait for single object, ensuring it waits for a shellcode execution to finish before continuing. This makes sure a shellcode runs completely before the script ends its execution. Alright, we have it now. On the attack box, execute the command netcat l. I prefer just L and VP use. Let's just use L and netcat L and VP. Double V means for more verbose. And we have port 1 BLV and P 1337. Right now we have started a listener which is going to wait for all the incoming traffic. So when we execute our shellcode, it will then return us the shell. On the attack box, begin by navigating to desktop, create a document, and then choose empty file. Open this file and paste the previously PowerShell script code into it. Look for the part labeled shellcode placeholder and replace it with the shellcode we previously created with MS Venom. Alright, so we go back, we copy this code. If you have time, you can also retype it. It would be, we'll learn much more. Nano, that'll be just payload. Paste, so probably be CS or something. Then I can just leave it here. Yeah, let's write payload for now. Once you have added the shellcode, navigate the VM, open PowerShell. Yeah, now you need to add the shellcode. So let's copy all of this. Copy. And then in payload, it was right here. So we're just going to paste it. Alright. You see it's all one line. Control S saves it. You have all the things down there if you open Nano. For example, first part, to copy and paste block is below. Once added the shellcode, navigate to attach VM, open PowerShell by clicking PowerShell icon taskbar and paste parts of code from the document you created to the PowerShell window. Alright, so we're just gonna paste it line by line. Am I right? Note, if your PowerShell terminal inexplicably closes, it means your netcat listener was not reachable, possibly because it was not running or it was listening on the wrong port or IP. Right, let's launch PowerShell. We are running as user's glitch. Once you execute the final line PowerShell terminal and press enter, you'll get a reversal in the attack box, giving you complete access to the computer even if Windows Defender is enabled. Now you can issue any command like issuing dir, which will list all the directories. Alright, so we can start by, let's go into Nano payload. We're using our type wait for. Alright, so we're just gonna paste line. I'm really going to paste line by line. Alright, I have the idea. Because I can't connect here, I will open my Remini client and create a new connection to a server called 10.10.87.117, username glitch, password, and then I'm going to connect. Let's see if it will work. I really hope so, because retyping this is pain. Yes, access certificate. Yeah, I've got this. I've got this, and right now in Remina I should be able to paste all that stuff there. Alright, this is the explanation. This is confessional connection. Yes, I am perfectly aware of it. And if right now I copy this and then paste it here, it works. Let's just try to run it. See what it will produce. Alright, you know what? I'm gonna do it one by one. I'm gonna first put this in. I'm gonna let's now wait for it to think. Alright, there it is. I'm just gonna now paste the second part. So it's not the Ctrl-Shift-V, that's Ctrl-V just. Well, I'm also gonna copy. Alright, add type virtual alloc. Now I'm going to paste this. Just copy and paste it again. Here it is. Alright, now we can add type wait for. Then we can add the last thing. Alright, so we found a solution for not copying stuff. Very good. Alright, then we paste the shellcode. So this is our shellcode. We can just copy, Ctrl-Shift-C here. Remina. Let's paste it here. And now we're copying one line at a time. Alright, so I just copied something weird. Let's copy this again and paste it here. One line at a time. Copy and paste it again. And now let's copy and paste it again. Alright. You see, that's how we've got the shell on our machine. Yeah, probably the VM will look like this. Yes, and it looks like this here. And then we have connection. We can right now glitch must act. Now let's go for the last thing. Now glitch must act. No time to delay. To fix the shellcode and keep foes at bay, he tweaks and he codes to set the rogues right, protecting his secrets with all of his might. Let's dive into the story and troubleshoot the issue in this part of the task. Glitch has realized he is no longer receiving incoming connections from his home base. Mayor Malware's minion team seems to have tampered with the shellcode and updated both the APN port, preventing glitch from connecting. The create IP for glitch is tagbox IP, and a successful connection port should be 44 only 4. So can you help glitch and find the shellcode? Was the value once glitch gets reverse shell using the for might to appear on desktop directory? Alright, so we have different port here, but let's hope it will work. We have different ports, so let's maybe just generate another shellcode. Now I should have watched at this looked at this earlier, and maybe I wouldn't have missed it. But yeah, let's maybe just kill this terminal, so it's gonna kill our shell as well. Yeah, but now after that's 1, 2, 3, 4, 4, 4, and we're gonna open it and copy all the stuff again. Yes, we're gonna get better at copying after all. Yeah, copy, and I mean paste. Now it works really fast. Paste. Now we can just copy this and paste. Yes, works like a charm. Copy and paste. Copy, paste. Copy, paste. Now we go to our terminal and get the shellcode. Copy and paste. Now we can continue with those, so we copy it. Give me the shell. Alright, something glitched again. Copy, paste, copy and paste, copy, paste, copy and paste. At this point we should have a connection, but let's check it here. Yes, we do. Let's now just go to cd desktop and directory. We'll just need to wait. All right, we are on port 444. Yes, we are. We are in PowerShell. We are everywhere. We can just click complete on here. Yay, our answer is correct. Glitch desktop. All right. It would take around a minute to appear. All right. Not door, but deer. Let's maybe look around somewhere. Oh yeah, you see? Here appeared the flag. Let's go back to cd desktop and type flag.txt. Get my access. Yeah, we got the access to you. AOC. Oh, they changed the instead of THM, they just got AOC. That's cool. So we just check documents as well. I'm kind of curious. Documents, directory, Windows PowerShell, nothing special. Alright, so thank you all for watching. I hope you enjoyed my little guide. If you like what I'm doing here, subscribe, leave a like, comment something positive, and yeah, that's really about it. See you in a while with day 9 and tomorrow with day 10. Cheers!